Hey guys, that was my son Lawson saying hello. These are some notes about similar figures. And as we talked about before, similar figures are figures that are proportionally the same. So one figure might be twice as big as the other, or 3 times, or some number like 2.5 times. So in this first section, we're just going to be talking about the scale factor. So when I say one figure is twice as big as the other, the scale factor would be 2. But we're going to write it as a ratio. So I'll show you how it's done, and I expect you to be writing these notes down. So in this first figure, you can see that this side of 6 corresponds to this side of 12. So I'm going to say that our ratio is 6 to 12. Now specifically it says the smaller figure to the larger figure. So here's the smaller figure and here's the larger figure. Now think of this as a fraction, like 6/12. I can reduce that to 1/2. So I can do the same thing with ratios. So I'm going to reduce that to 1 to 2. That means for every 1 there is on the smaller one, there's 2 on the other one. So something 6 on the smaller one, the bigger one is 12. Okay, let's move on to the next one. So it doesn't matter which pair of sides we pick, but they have to be the corresponding sides. So for example, I wouldn't want to pick 14 and 40 here, because 14 is this smaller side and the corresponding side on the bigger triangle is this side, and we actually don't know how long it is. So I'm going to pick the 15 and the 6, and I'm going to go smaller to biggest. Now, a common factor between 6 and 15 is 3, so I'm going to divide each one by 3, and then I have 2 to 5 as my ratio. You can pause it now and try to do the next two on your own, and then restart it. Okay, so for this next one, I'm going to do 24 to 30 as my ratio. 6 is a common factor, so I'm going to divide each of them by 6. So I'm going to get 4 to 5. Now in this last one, I could either use the 12 and the 6 or the 14 and the 7. So I'm just going to use the 7 and the 14. 7 to 14, which is 1 to 2. For this next section, we already know that the polygons are similar, so we're going to use the fact that they're proportional to find a missing side. You just have to be careful that you're matching up the right corresponding sides. So in this one you can see that there's these 2 congruent sides which match up to these 2 congruent sides. So we know that one of our fractions can be 48 over 40. So 48 being a side on the larger figure that corresponds to the side of 40 on the other figure. And I'm going to set that equal to, and I'm going to use, since I'm looking for this side, that corresponds to the 42, so I'm going to use 42 over x. Now it's really important to notice in this situation that these 2 numbers are from the same polygon. So the 48 and the 42. So the top numbers have to be from the same polygon. Okay. Now I'm going to go ahead and cross multiply. So I get 48x equals 1680. And then divide both sides by 48. So I get x equals 35. Okay, let's try that again. So in this triangle, you can, or not triangle, quadrilateral, you can see that there's these 2 congruent sides that match up with these 2 congruent sides right there. So our corresponding sides are going to be, one second here. Okay. Our corresponding sides are going to be 24 and 32, and then 21 and question mark. So I'm going to go 24 over 32 equals, now since I started with 24 on top, I got to start with 21 on top of the other fraction. And then I'm going to cross multiply. So 24x equals 672. That's what I get when I multiply 21 and 32. Divide both sides by 24. So I get x equals 28. All right, now it gets a little trickier here just because we have this binomial situation, but we know how to solve proportions with binomials. Also, in these harder problems, the figures are going to be oriented the same way, so it's a lot easier to figure out what the corresponding sides are. Here I can see this x plus 5 corresponds to the side of 12, and the side of 20 corresponds to the side of 15. Okay, so I'm going to go x plus 5 over 12 equals 20 over 15. Again, remember that you have to match up the tops. So these both come from the same figure. All right, now I'm going to keep working. So I'm going to cross multiply. So I have 15 and then times x plus 5 equals 20 times 12, which is 240. Now I got to distribute. So I got 15x plus 75 equals 240. Now I need to just subtract 75. So I have 15x equals 165. And then divide both sides by 15. And I get x equals 11. Okay, last problem. All right, so I have extra sides here that I don't even need, but most importantly, I want to match up x plus 14 with the side it corresponds to, which is the 20. And then I can pick any other pair of corresponding sides. So I could pick the 18 and the 15, or I could have done the 42 and the 35. I don't have this other side, which is the one that corresponds to 41.4, so I can't use that one even if I wanted to. All right, so I'm going to go x plus 14 over 20 equals 18 over 15. So just last reminder to make sure that these top numbers come from the same polygon. All right, then we cross multiply. So 15 times x plus 14 equals 18 times 20, which is 360. Now I'm going to distribute. So I have 15x plus 210 equals 360. Subtract 210. So 15x equals 150. And then divide both sides by 15. So x is 10. That's the end of the video.